What if I told you that in 2025 we're about to discover more about the universe in 10 years than we have in the entire history of human civilization? The Vera Rubin Observatory is about to change everything we think we know about reality itself. High in the Chilean Andes, at 2,600 meters above sea level, something extraordinary is stirring, a technological marvel that will peer deeper into the cosmos than any instrument before it. This is not just another telescope. This is humanity's next great leap into the unknown. For centuries, we've gazed upward, wondering what secrets the night sky holds. We've built increasingly powerful eyes to pierce the darkness, each one revealing new mysteries, new questions, new wonders. But the Vera Rubin Observatory represents something fundamentally different. It's not just looking deeper or further. It's about to show us the universe as it truly is, dynamic, ever-changing, alive with phenomena we've barely begun to understand. At the heart of this revolution lies the most ambitious camera ever conceived by human minds, the Legacy Survey of Space and Time camera, the LSST camera. Imagine, if you will, a digital eye so powerful it could photograph a golf ball from 15 miles away. This is no ordinary camera. With 3.2 billion pixels, that's 3,200 megapixels. This extraordinary instrument will capture images so detailed, so vast, that each photograph will contain more information than the human brain processes in a lifetime. To put this in perspective, if you wanted to display just one image from this camera at full resolution, you would need 378 4K television screens arranged in a perfect grid. But it's not just about the numbers. This camera will be cooled to minus 100 degrees Celsius, operating in conditions that would instantly freeze human blood. Its sensors are so sensitive they can detect individual photons that have traveled billions of years across the cosmos to reach us. Every night, this mechanical marvel will capture 15 terabytes of data, equivalent to taking 6 million smartphone photos every single night for 10 years. Think about that for a moment. Every photon that strikes this camera carries with it the story of its journey across space and time. Some of these particles of light began their voyage when the universe was young, when the first stars were being born. And now, in this moment, they're completing their epic journey by striking silicon sensors in a mountaintop observatory in Chile. The camera, magnificent as it is just one part of a larger symphony of engineering brilliance. The Simoni Survey telescope itself is a masterpiece of optical precision. Its 8.4-meter primary mirror, that's 27 feet across, is not just large, it's revolutionary. Unlike traditional telescopes that peer at tiny patches of sky, this telescope has been designed with a field of view 40 times larger than the full moon. In a single exposure, it can photograph an area of sky equivalent to 40 full moons side by side. This isn't just impressive, it's transformative. But here's where it gets truly extraordinary. The telescope's three-mirror design creates images so sharp, so precise, that stars appear as perfect points of light across the entire field of view. No distortion, no blurring at the edges. It's as if we've created a perfect window into space, unmarred by the limitations that have plagued astronomers for generations. The mirror itself is a work of art, polished to a precision of 10 nanometers. That's 10,000 times thinner than a human hair. If this mirror were scaled up to the size of Earth, the largest imperfection would be just 6 feet tall. This level of precision allows the telescope to collect light with an efficiency that borders on the miraculous. Every night as the Earth turns, this telescope will sweep across the sky like a cosmic lighthouse, capturing the universe in motion. And motion, as we're about to discover, is everything. Behind every great discovery lies an even greater challenge. What do you do with more information than has ever been collected before? The Vera Rubin Observatory will generate 20 terabytes of data every single night. In 1 year, that's more data than the entire internet contained in 1995. This is where the data management system becomes not just important, but essential to our cosmic future. Imagine trying to find a single changing star among 20 billion stars night after night for 10 years. It's like searching for one specific grain of sand on all the beaches of Earth, except that grain of sand might be moving, changing color, or disappearing entirely. The system that handles this data is a marvel of computational engineering. Within 60 seconds of taking an image, sophisticated algorithms will have analyzed every pixel, identified every object, and compared it to every previous observation. It's like having a perfect memory of the entire visible universe, updated every few nights forever. But this isn't just about storage and processing. This system will learn. Machine learning algorithms will identify patterns that human minds could never detect. They'll spot the subtle dimming of a star that indicates a planet passing in front of it. They'll catch the first light from a supernova explosion happening in a galaxy billions of light years away. They'll track asteroids that might one day threaten Earth. The data from this observatory won't just be available to a select few astronomers. It will be freely available to anyone, anywhere in the world. A student in Mumbai, a researcher in Sao Paulo, a curious mind in Manchester, all will have access to the same cosmic data set. We're not just building a telescope, we're democratizing the universe. In the vastness of space, change happens on timescales that dwarf human experience. Stars are born and die over millions of years. Galaxies collide over billions. But some cosmic events happen fast, explosively fast. And for the first time in human history, we're about to catch them in the act. The alert processing system is perhaps the most thrilling aspect of the Vera Rubin Observatory. Within minutes of detecting something new or changing in the sky, alerts will be sent to observatories around the world. Imagine the moment when this system detects the first light from a star being torn apart by a black hole, or the gravitational wave signature of two neutron stars colliding. This system will identify up to 10 million alerts every night. Most will be false alarms, cosmic rays hitting the detector, aircraft passing overhead, satellites glinting in the sunlight. But hidden among these millions of alerts will be the discoveries that rewrite textbooks. We'll catch supernovae in their first moments, when the shockwave is still breaking through the star's surface. We'll spot asteroids that we've never seen before, some of which might be on collision courses with Earth. We'll detect the subtle dimming patterns that reveal planets orbiting distant stars. But perhaps most exciting of all, we'll discover things we don't yet know exist. The universe has a habit of surprising us. Every time we build a more powerful instrument, we find phenomena that our theories never predicted. The Vera Rubin Observatory will undoubtedly reveal cosmic mysteries that we haven't even imagined yet. The final piece of this cosmic puzzle is perhaps the most elegant: the survey strategy itself. For 10 years, the Vera Rubin Observatory will execute a carefully choreographed dance across the sky. Every patch of the southern sky will be photographed repeatedly, building up a time-lapse movie of the universe. This isn't random. Every observation is planned with mathematical precision. The telescope will revisit each area of sky multiple times per year, in different colors of light, building up a four-dimensional map of the cosmos, 3 dimensions of space and 1 of time. Over the course of the survey, we'll create the deepest, widest, most complete movie of the universe ever made. We'll watch galaxies evolve, stars explode, and black holes devour matter. We'll track the expansion of the universe itself, measuring how dark energy is accelerating the cosmos toward an uncertain future. But perhaps most profoundly, we'll finally begin to understand the 95% of the universe that we currently know nothing about. Dark matter and dark energy, the invisible scaffolding upon which all visible matter hangs, will finally begin to reveal their secrets. This observatory will show us that the universe is not the static, unchanging realm our ancestors imagined. It's a dynamic, evolving, living entity. Every star, every galaxy, every particle of matter is part of an ongoing cosmic story that began 13.8 billion years ago and continues to unfold around us every moment. And we, curious, questioning, wondering humans, are about to become the first generation to truly see this story in all its magnificent complexity. The Vera Rubin Observatory isn't just going to change astronomy, it's going to change us and our understanding of our place in this extraordinary universe we call home. The cosmos is waiting, and very soon we'll be ready to listen to what it has to tell us.